determine the correct derating for 535.3 MCM locomotive cable installed in PVC conduit underground with 3 conductors per conduit, we need to follow a step-by-step process. The manufacturer provides a free air ampacity rating of 725 amps per conductor. However, installing multiple conductors in a conduit reduces the ampacity due to heat buildup. Firstly, determine the ambient temperature. The ambient temperature of the conduit installation site is crucial for calculating ampacity derating. Obtain this information from local climate data or building codes. Secondly, calculate the ampacity derating multiplier. Utilize Table 310.16 of the National Electrical Code, NEC, which provides correction factors for conductors in a conduit. According to Table 310.16, for 3 conductors in a conduit, the correction factor is 0.8. This factor accounts for the reduced heat dissipation when multiple conductors are bundled together. Thirdly, apply the multiplier to the free air ampacity. Multiply the manufacturer's free air ampacity rating, which is 725 amps per conductor, by the correction factor of 0.8. This calculation will provide the derated ampacity for 3 conductors in a conduit. The calculation is as follows: derated ampacity equals free air ampacity multiplied by correction factor. Derated ampacity equals 725 amps multiplied by 0.8. Derated ampacity equals 580 amps per conductor. Therefore, the correct derated ampacity for 535.3 MCM locomotive cables per conduit is 580 amps per conductor. This value accounts for the space limitations and heat dissipation constraints within the conduit. In summary, to properly derate the locomotive cable, firstly, find the ambient temperature. Secondly, determine the NEC correction factor for 3 conductors in the conduit. Thirdly, multiply the free air ampacity by the correction factor to obtain the derated ampacity. Always consult the latest edition of the NEC and local electrical codes for the most accurate and up-to-date information.